Cállate. Okay, so I'm gonna talk about topic number 3, that it's scalar and vector quantities. We understand that a scalar quantity is described only by its magnitude, meaning no direction added, and a vector quantity is specified by magnitude and direction, meaning how, we can say it like this, how fast is the object going and where is it going. So we're gonna take a look at. So scalar is a quantity described only by its magnitude, meaning no direction. For example, we can have distance, speed, or volume. We have more examples, but these are just a few of them. So we can say distance is like 12 kilometers. So we can say a guy took a hike, a 12-kilometer hike, but we're not specifying where or in what direction. Speed, 15 miles an hour. So a car is going 15 miles an hour. We're not saying where is the car going or anything like that. Volume, okay, that's very easy. 200 centimeters cubic. So we just are not specifying any directions in this. So these are scalar quantities. Now vector quantities is a quantity specified by magnitude and direction, meaning how fast, how strong, and where. For example, we have displacement, velocity, and force. So we can say in displacement 20 meters north. So the guy hiked 20 meters north to the mountain. So we say so we know how far and where did he travel. Velocity, 40 miles an hour, 30 degrees north of west. So we know how fast is the car going and where is it going. Force, 50 newtons going 135 degrees. So we know where is the force being applied, where is the force going. As we can see, the vector quantities have an arrow pointing, they are having a direction added. So we say D, this is a vector magnitude, meaning displacement, V for velocity, and F for force. So now we know that scalar is just a car going this fast, and a vector quantity is a car going this fast towards this object, meaning north or something. Now we're going to talk about a graphic representation of a vector in 1 or 2 dimensions. So, a vector is a graphical representation of a vector quantity. It is represented by an arrow, meaning the length of the arrow, the length of the magnitude, and the direction of the arrow is going to be the direction of the magnitude going. Where is it going? That makes it a vector quantity. So as we can see here, again, the arrow, the length is the magnitude, and it's pointing at some direction. Now for a graphic, we have scales because sometimes it's not enough space we have in a piece of paper to represent it like in a real way. So for example, we have 5 newtons going east, and we have the scale 1 to 1. So we are going to draw 5 centimeters of the arrow. Let's say this is 5 centimeters pointing east. Let's say it's pointing to the east. So that's how we represent a vector in a graphic. Now we're going to talk about the analytical representation of a vector. For any vector with magnitude r and direction of an angle, r meaning like any magnitude, we can obtain its components along the x and y axis in a graph. The x-axis is the one that is horizontal and the y-axis is vertical, using the following formulas. Let me show you. For any vector with a magnitude and a direction, meaning an angle, because it's going to be in a graphic, we can obtain its components along the x and y axis with this formula. This for x-axis, it's going to be rx equals r cosine of the angle. And for y, it's going to be ry equals r sine of the angle. So for example, if we say we have a force of 200 newtons at 60 degrees, how are we going to represent it in a graph? So we're going to use these two formulas for each of the quadrants. That's going to be x and y. So we're going to solve it. Fx is going to be equal to f cosine of the angle. So f, we're going to substitute it. F is equal to 200 newtons. Cosine of the angle, that's going to be 60 degrees. And the answer is going to be equal to positive 100 newton. Now for y. Fy equals f sine of the angle. F meaning 200 newtons again. And sine of the angle that is 60 degrees. So we're going to have a different answer because we have different formulas, different multiplications, different equations, and different functions. So it's going to be positive 173.2 newtons. Here is how we represent it in the graph. 200 newtons. This is the graphical representation of a vector, as we saw it in the theme before. Pointing 60 degrees up. That's it for today.